Yeah, so the Indian chemical industry is going through a transformation where the rest of the world is seeing it as another kind of reliable source of supply of chemicals. Specifically, when it comes to the fine chemicals, specialty chemicals, and the pharmaceuticals, we are already a leading country, and our manufacturing sector is booming in that direction. But what is more important is that as we keep on improving our turnovers, as we keep on increasing the capacity that we want to build, we are using more and more resources in the more conventional manner. We need to change that because in general, the chemical industry is seen as something which is kind of a polluting industry. It is also seen as an energy intensive industry. So the entire picture about this needs to be changed either by changing the chemistries that we are working with or by re-engineering the plants. The first part is already taken care to a significant extent by a large number of chemists. The second part is something which is important for process engineers to contribute. So with this, what we feel is that in the time to come, the chemical plants need to be compact, more robust, very efficient, and extremely reliable in terms of the consistency in the production. All these things are possible entirely by using continuous manufacturing. Continuous manufacturing is going to be the future of chemical industry from India all over as well as all over the world. In NCL, we are working in this domain for the last 15 years. We have worked with kind of more than 60-65 clients over this period, and kind of at this point of time there are more than 200 industries in India who are trying to get into this domain. At this juncture, we felt that the initiative that came from Chemdist was timely, that NCL and Chemdist can work together in transforming the lab scale proven processes into the pilot scale and commercial scale manufacturing processes. So in general, when you look at any chemistry being done at the lab scale, what is the typical approach is what we chemical engineers call it as the batch process. Even when we make a cup of tea at home, it is batch process that we follow. We basically take some water, add some tea powder, boil it, add some sugar, then we add some milk, and after that we filter that, and then we kind of have the tea. Now this each step we chemical engineers call it as unit operations, and if you see in a batch protocol, these are all done in sequence in time. While in the continuous process, this all happens continuously where the time is irrelevant, and each of these steps are followed one after the other seamlessly without any interference from anybody. Typically, when you look at the chemical plants, the batch protocols, when they are followed, as we all experience, every day when we make a cup of tea, it tastes differently. The same happens in the chemical plants also. As a result, there is an inconsistency in the quality of the production and inconsistency in the time that is required for completion of a batch protocol. By making it continuous, this particular issue will be taken care, and so the production will become consistent and it will become an automated thing where people don't need to kind of interfere during the process. So this will make sure that so far the raw materials are supplied to the plant, so far the utilities are kind of taken care properly, the product quality will be consistent. And it is not just the reaction part, but even the further separation, purification, all can be done consistently, continuously by integrating with the reactor. So that is what the continuous manufacturing platform will do.